Howdy and welcome to Advent of Code 2022. I'm about to do day 24, the last hard puzzle of this whole thing. I'm really excited to get this done, so let's get started. Blizzard Basin. With everything replanted for next year, and with the elephants and monkeys tend to the grove, you and the elves leave for the extraction point. Partway up the mountain that shields the grove is a flat open area that serves as the extraction point. It's a bit of a climb and nothing expedition can't handle. At least that would normally be true. Now that the mountain is covered in snow, things have become more difficult than the elves are used to. As the expedition reaches a valley that must be traversed to reach the extraction site, you find that strong turbulent winds are pushing small blizzards of snow and sharp ice around the valley. It's a good thing everyone packed warm clothes can make it across safely. You'll need to find a way to avoid them. Fortunately, it's easy to see all of this from the entrance to the valley, so you make your map of the Valley of the Blizzards. For example, the walls of the valley are drawn pound, everything else is ground, clear ground where there's currently no blizzard, drawn as dot, otherwise blizzards are drawn with an arrow indicating the direction of motion, up, down, left, right. The above map includes two blizzards, one moving right, one moving down. In 1 minute, each blizzard moves one position in the direction it's pointing. Due to conservation of blizzard energy, as the blizzard reaches the wall of the valley, a new blizzard forms on the opposite side of the valley, moving in the same direction. After another minute, okay, so they wrap. So it wraps. Because the blizzards are made of tiny snowflakes, they pass right through each other. So they occupy the same position, mark 2. After another minute, the situation resolves itself and they keep moving. Okay. All right. Here's a more complex example. All right. Wow. Okay. Your expedition begins in the only non-wall position in the top row and needs to reach the only non-wall position in the bottom row. On each minute, you can move up, down, left, right, or you can wait in place. You and the blizzards act simultaneously, and you cannot share a position with a blizzard. In the above example, the fastest way to reach your goal requires 18 steps. You can move down. Down, wait, up, right, down, left. Oh, wow, okay. This is going to be fun. What is the fewest number of minutes required to avoid the blizzards and reach the goal? Okay. Let's get our puzzle input. So we need to track the position of every blizzard and which way it's facing. And then in each iteration, we check the possibilities for where to go. So sometimes you can wait and sometimes you can't, right? If there's a storm moving towards you, you can't wait, right? So if we go to this wait here, there's no storm moving right into you. So it's like, but on the next turn, there's no position you can move. So you have to wait. So I think in most cases, because this input is so full, we're not going to have that many choices. But we will have choices, so we'll have to do a recursive splitting, which means it'll take a while to run. All right. Let's start with implementing it. All right. Okay. So now we're just doing like the iteration of the blizzard so we know where they are. Okay, yeah, it should be fine. Okay, we have the next blizzards here. State's going to be a list of blizzards and position. Well, we need to know the width, right? So we need to know the map. Okay. So this next is determined by the map. Nice. Okay. Wait for this to okay. Then, so we have our next location and we just need to check if it's off the map. I'm just going to do this one by one. It's not that hard. So we're going to do 0 to, so if the height is here 4, and this is 0, then when we get past index 4 to 5, then we're at the bottom. So if the row is equal to map.height, then return blizzard location where the row is 1. So we're going to wrap to 1. Self.look.call self.dir. Else self.look.row plus 1. Nice. All right, so now we're just gonna redo this 4 times. Let's do up. And in this case, if the row is equal to 1, then we wrap to map.height. We do -1 here. All right, change this to an elif. Do down will be left. No, down will be right. And then left. Okay. So if the call equals map.width, then we do self.look.row here with wrapping to column 1. Otherwise, we add 1. And if we're going left, then we want to make sure we are not in the column of 1. And then we do -1. All right, so there we go. And we'll make this an else with a pound there. Okay, so now we have the next blizzard, moving it off the map or whatever. Okay, so we did that. And then we need to make a recursive solver for this that handles every possible outcome. And we're gonna do a breadth first search, which means that we're going to increment we're going to get a list of every possible state at each iteration. And the first state to reach the end is our winner. And since this blizzards will be in this, we only have to calculate the blizzards once for every state. And any states that's in the same position, we collapse if they got there through 2 different ways. So yeah, that's cool. All right, so from any given state, we need to evaluate next positions. So possible iterations, next states, self, every state is a list of possible positions. Haha, list of locations. Hey, hey, yeah. Okay. Next blizzards equals b.next. We need a map. Map. b.next self.map for b in self.blizzards. Blizzard next blizzard locations equals the set of b.look for b in next blizzards. Okay. And then and then for every position we evaluate moving up, down, left, right, and staying in the same place. And if any of them are not in the next blizzard locations, then it's a possible location. So next positions equals possibility for possibility in, hold on a second, for position in self.positions Okay, position, I'm gonna do for pos, so make it smaller, pos. We do pos dot up, pos dot down, pos dot left, pos dot right. If this possibility possible position, that's what pos means. Possible position if map.in map p pos and p pos not in next blizzard locations. Return state blizzard map equals self.map blizzards equal next blizzards positions equals next positions. Def solved. Return any pos self.map.is at end pos for pos and self.positions. So if any of the positions is in the end position, then it's solved. Okay, do we need to implement an init here? Def init self input. So self.map equals map input. So we're going to do an init there. Self.blizzards equals blizzard location I j direction input.lines I j. If input.lines I j in up down left right up down caret, I need the bottom, I need the down here. All right, so if the character is in there, then it's a blizzard. For I in range len input.lines, for j in range len input.lines I. All right, so there. And then positions, elf.positions equals location row 0 self.map.start column. Okay. All right, and the map needs an input. Width, the self.width equals len input line 0. Height is that, right? No, height is that -2, right? -2 and -2, right? Because we don't want to include the walls. And then start call equals len equals I for I in range len self.width if input.lines 0 I is equal to a dot, and we just get the first one. We do the same thing for the end column. The end column is the height plus 1 here, so the height plus 1. So 0, 1, 2, 3, 4, 5. is your index here. Okay, and then we have to do def in map self location boolean if loc.row is equal to 0, then return loc.call equal to self.start column. Elif loc.row is equal to self.height plus 1. Return loc.call equal to self.end column. Else return, so that means the rows in between the return 0 less than loc.row less than or equal to self.height. So it can be from 1 to height. So yeah, we can just do 1. We do the same thing, and 1 less than or equal to self.loc.column self.width. Okay, so that's the in map. I think that's all of our functions. Cool. So we just need to do state. So we do state equals state input while not state.solved round equals 0 state dot equals state dot next state round plus equals 1 return round. Okay. We're going to do the complex example. List index out of range, input.lines, self.height -1. Oh, we got to do self width plus 2 here. Wait. No. We start when we're looking for the column. This is column 1, right? So we're calling this 0, 0. So when we move across, we need to go width plus 2. Lines. Oh, okay, so it's saying that. Oh, right. So this one didn't work because we only went up to here, and yeah. Okay, so we just fixed that bug. Okay, cool. And I just want to check that our blizzards have the correct position. Yeah, so blizzard's just IJ in the lines, which is, yeah, so we're using absolute indexing, and then our in map is just checking that you're within the walls. Oh, we need an is at end function. Location has no up. Yes. Okay, implemented those things. Type map has no attribute in map. What do you mean? Yes, it does. Day 24, line 118. Self.map. And it got an unexpected keyword map. Parse got an input. Self is not defined. $18. 18. Yep. Okay. All right. We got it right for the example. Let's do the input. See how long it takes. Oh, we forgot to do the merging, right? Let's make this a set. $228. Nice, did it right. Yeah, that set merging was really key. Part 2. As the expedition reaches the far side of the valley, one of the elves looks especially dismayed. He forgot his snacks. Since you're so good at dodging blizzards, the elves humbly request that you go back for his snacks. For the same initial conditions, how quickly can you make it from the start to the goal, then back to the start, then back to the goal? Okay, cool. So how do we want to modify the state? We want to modify like goals. We want to have goals. So the goals start out as false, false, false. So got to end, got to back again, and then end again. So once you actually, we can remove all, once we've solved once, we can just start again. So actually this state needs a goal. Goal position. So the goal position when initializing is going to be map dot height +1 map dot end column. And that's the goal position. And then solved means any position is equal to self dot goal position. Okay, so then then we just like redo the solution over and over again. Okay, so we start with the state. We have round 0, first round, then we reset. We say state equals the current state, a new state, where we take state.map and we do blizzards. We just take the current state of the blizzard, state.blizzards. We don't change anything, but the positions is now just the end position. So we start with the goal position. So state.goal position. But then the new goal position is the start. So we're gonna do start pos equals location 0 state.map start call. And we get the end position, state.map.height plus 1, right, and end call. Okay. Nice. All right. So it's initially going to parse itself and then set its goal to the end position. So once we reset, we start at end position, and the goal position is start pos. And then we execute again. Nice, like that, like so. And then we redo it. This could certainly be cleaner, but whatever. So now we're starting at the start position again and going to the end position, and we do third round here. We return first round plus second plus third. We're going to do a few prints. I have to spell things correctly. Nice. Okay. Let's do it on the example. First traverse in 18, 23, 13, correct. For total 54, we do the input, 723. Nicely done, we did it right. Woo woo! Good job us. That was pretty fast for the last problem, so I'm really happy with the solution. Like we knew how to build the solution with this sort of like breadth first search, and we realized that we could reduce the search space because all the positions are equivalent when you're at the same iteration, so we didn't have to keep track of multiple iterations of blizzards. So I really think we did this one straight on really good. And then yeah, just adapting our solution, have a goal position for the second part, really good. So happy about this one. We got one more to go. I'm gonna record it right after this, so see you there. Peace.